Hi, welcome to example 7. In this example, we will be looking at a forced ventilated process building that encloses a pump skid handling pentane. The building is forced ventilated. Given that we expect only secondary grade release sources within the building, we need to consider the single most likely and worst case leak source. This would likely be the pump seals, as they are moving parts under pressure. The pumps handled pentane at a process temperature of 50 degrees Celsius, with a discharge pressure of 450 kilopascals. A 2 meter by 1.5 meter containment dike surrounds each pump to collect any fluids leaking from the pump seals. Ventilation for the building is provided by one continuous ventilation fan mounted high, and 4 louvers mounted low in the building. A second high-rate emergency ventilation fan is interlocked with gas detection. The second fan does not factor into the classification design, as it does not operate on a continuous basis. It is intended to control a large-scale containment release, and only operates when a gas detector detects a vapor release of greater than 25% of the LFL. The ambient temperature within the building is maintained at 25 degrees Celsius. We want to achieve a Zone 2 classification for this building. Our objective is to determine the appropriate level of ventilation necessary to achieve this goal. Let's use ExHAC to perform our analysis. First, we create a new project and enter the required information. This is example 7. We will name the project Forced Ventilated Enclosure. The altitude is 100 meters. Minimum ambient temperature is -32. And the maximum ambient temperature is 40 degrees Celsius. The location is an oil battery. And the user project description will be pentane pump building. Click Submit once you are done. And the project appears in the project list. Next, we select the compounds involved in the release. Search for pentane in generic compounds. And since it is already there, we don't need to create a new compound. Next, we go to the FM module and configure a flammable mixture for pentane, since it is not found here. Enter 100 in mole% of N-pentane. And click Save. Next, we go to the FM Analysis tab. Select pentane. And click on Start Analysis. The properties of pentane are displayed on the right. Now, we need to create the source of release. We will name this example pentane pump release. The release source will most likely be a pump seal in the vicinity of the pumps, resulting in a pull release on the pump containment. So, we select liquid pull release. The stream temperature is 50 degrees. And pressure is 450 kilopascals. The grade of release will be secondary because the release is not expected to occur during normal operation. Ambient temperature is 25 degrees. Save your SOR. And make sure it appears on the list. Before we configure an enclosure, we need some information on the building dimensions. We also need to determine where our ventilation fans are installed, as these walls will define the building length. In our case, the ventilation fans are on the 5-meter wall, so this becomes our building length. This detail is important when ExHAC calculates the ventilation velocity in the building. Let's create an enclosure in ExHAC to model this building. Next, create an enclosure. We will label it Pentane Pump Building. We will define the length of the enclosure as 5 meters, based on our previous discussion. The enclosure width is 8 meters. And the enclosure height is 4 meters. The volume of the building will be automatically calculated for us. Since the building is forced ventilated, we will leave naturally ventilated as no. We can further describe the building as being forced ventilated. Now, let's configure the hack. We will select example 7 as our project. Pentane as our flammable mixture. Pentane pump release as our source of release. And the pentane pump building as our enclosure. Enter configure analysis to begin our assessment. Now, let's review the hack parameters and fine-tune them for our assessment. Pentane vapors are heavier than air, so the default type of release for a heavy gas is appropriate. The wind speed, in an enclosed application, refers to the wind speed outside of the enclosure. This will influence the need for a classification extent outside of the enclosure. We will leave this as 0.3 meters per second. The pool surface area will be based on the containment pan, under a pentane pump. The size of the containment pan is 1.5 meters by 2 meters, for a total pool size area of 3 meters squared. The wind speed across the pool is a function of the ventilation velocity for the enclosed area. This is correlated with the forced ventilation rate we select for the building. ExHAC will provide a starting value for this parameter once we define the ventilation rate for the building. And press Start Analysis. We can review this parameter and modify it later if needed. The availability of ventilation is defined as good, as we expect the ventilation fan to be in continuous operation. The ventilation inefficiency factor is a measure of how uniform the area is ventilated. We can click on the parameter to get a detailed explanation of how to estimate this parameter. In our example, we have a relatively uncongested building, with good airflow, throughout the enclosure. We will accept the ExHAC default value of 1 for this reason. Finally, we will specify a forced ventilation rate of 425 meters cubed per hour. This corresponds to a ventilation rate of 250 cubic feet per minute. Our EVAC ventilation rate is specified as 1,700 meters cubed per hour, corresponding to a ventilation rate of 1,000 cubic feet per minute. Press Start Analysis to begin the assessment. Let's now review the wind speed at pool surface value, based on our ventilation design. We see that ExHAC has estimated a wind speed of 0.006 meters per second. We can choose to accept this value, or modify it to reflect actual site conditions. This parameter, in addition to the pool size and ventilation efficiency, will heavily influence the result of our assessment. We need to consider values that reflect our application. For our example, we will accept the 0.006 meters per second value for wind speed at pool surface that ExHAC has calculated. Now, we can review our simulation results. ExHAC indicates that the ventilation rate we have selected does not achieve our goal of a Zone 2 classification. For an enclosed area to achieve a degree of medium dilution, the ventilation velocity must be in the medium section of the chart, and the background concentration must not exceed 25% of the lower flammable limit for the flammable material. We can see that our enclosure will have a background concentration of 27%, and therefore fails the background concentration check. We cannot consider the enclosure to have a medium degree of dilution. Let's increase the forced ventilation rate to 850 meters cubed per hour, equal to 500 cubic feet per minute. And press Start Analysis. Notice that ExHAC has provided a new value for wind speed across the pool surface, based on our new ventilation rate. Let's now review our results. We go to the ExHAC Output tab. And we see that we have achieved a medium degree of dilution, with a background concentration of less than 25%. This permits a medium dilution assessment, allowing a Zone 2 classification to be applied to our enclosure. Now, before we move on, we should consider if a classification is warranted on the exterior of the building. This will account for a potential release through doors, windows, and ventilation openings. One possible means of making this assessment is to look at Figure C.1 and determine the degree of dilution based on the exterior wind velocity value. Our exterior wind velocity was estimated to be 0.3 meters per second. Here we see that it falls into the medium dilution area of the chart for our release characteristic. This would imply that an exterior classification may be warranted. By default, ExHAC will apply a minimum 1 meter extent, surrounding all enclosure openings. The extent of the exterior classification can be based on Figure D.1 for our release characteristic value. ExHAC estimates a vertical extent of 1 meter and a horizontal extent of 2.13 meters. We can apply these values to our classification diagram. If we are satisfied with our results, press Save Analysis. To create a report, go to the HAC Analysis list. And select Create Report for our forced ventilated enclosure application. A summary report of all the input and output parameters will be displayed. We can choose to save our report in our HAC report list for later retrieval within ExHAC, or export the report as an Excel file for archiving purposes. The Excel version of the ExHAC report can then be modified to incorporate any other sources of release considered in the assessment. Our classification diagram will look like this. We have defined the interior of our process building as Zone 2, with a 2.2 meter horizontal extent on the exterior of the building. Within the building, we do need to consider areas where a Zone 1 classification would be appropriate. This may include areas that are not well ventilated, such as the containment pan under the pumps and the area below floor level. Once we define the group and auto-ignition temperature, our assessment is complete. We can incorporate our diagram into the overall classification design for our facility. Our hazardous area classification design for this forced ventilated enclosure application is now complete.